Okay. Hi, Sonali. How are you?
I'm good. How are you?
Yes, fine. How's your camp going on? Has it started or not?
Oh yes, it started. It's going good.
Okay. So you're teaching art classes, right?
I used to teach art classes, but I stopped for the summer.
Okay. So what are you taking now?
I'm not teaching any classes, but I'm doing a research project right now.
Okay. Wow, that's great. Okay. Okay. So let's start with the today's session. Before that, I'll just tell you about your project percentage report is 100%. You've completed all your projects. And the quizzes are also complete, so very good. Keep up the same pace of working. And what doubts did you face in your project last time? I mean, into activity 4?
Yes, I didn't understand. If I remember correctly, I wasn't really sure how to put it all together.
Okay.
Uh, yeah, I was. I don't think we went over it completely in class. Um, it was It was like a mix of classes, and I think
Okay.
I got a bit confused.
Okay, great. No worries. I mean, but then you were able to complete it and it was running, right?
Yes. Now it's all good.
Okay. Okay, so let's quickly recall the last class and then I'll just share my screen first. I hope you're able to see my screen.
Yes, I am.
Okay, so you know these steps. First of all, saving the lesson in my drive. Do you remember what did we study in the last session?
Yes, learned about uh, we learned about like scatter plots and regression lines, and plots, and we went over. I think we learned about different data points. There's a lot of math involved and statistics involved,
Yes.
and how to
And
put that into code.
we learned few of the formulas.
Yes.
Do you remember those?
I don't have the formulas memorized, but I understand how we put it together.
Okay. We'll just quickly recap the last class and then we'll start with the new session today. We'll be
Okay.
learning today the simple linear regression model only, and we'll be learning the error analysis. I mean, how much kind of error is there in the analysis. So that we'll be learning today. Okay.
Okay.
I've shared the lesson with you. Share your screen and do open that. The name of the analysis is residual analysis, which we'll be learning today. Okay. Which is simply calculating the accuracy of the simple linear regression model. Okay. The model we had learnt last time, all the formulas and everything we had seen last time. Now we'll be analyzing the error in this prediction analysis. Okay.
Okay.
So we'll quickly recap the last session. Can you just quickly explain me what did we learn this? Yeah, this code.
So here we're importing the modules and
Yes,
loading the data set. And
correct.
then here we're dropping two unnamed columns and also the null values.
Yes,
Over here we are creating a panda series with the datetime objects, and we're removing the date and time columns and making a date time column, putting it together. And then here we have panda series for the year values, month, and day values. And here with the days of the week, their names.
yeah,
And we're adding all of those to the data frame.
yeah, that's correct.
Here, here we're sorting values, the daytime values in ascending order.
Yeah.
Here we're creating a function where we'll replace the commas with periods, and we're applying it here to these different columns. Here we're removing columns with more than 10% garbage value, and we're creating new data frame data frames for these years.
Yes, for 2004 and 5 we saw.
Yes.
Okay.
And then here we're replacing negative 200 with the median value. And this is for 2004, this is for 2005. And then we're grouping the data frames by the month column for both years again.
Yeah.
And then we're concatenating the two data frames for both the years uh, into one data frame. And then here we're just getting the information.
Correct.
Yeah.
So according to this info, we are having all the columns along with the non-null values and their data types, right?
Yes.
Okay. Now just scroll down. This is the description given to you for all the columns. That also we had read. And we had read the two columns, which can you just name those two columns for which we had done the analysis?
We did relative humidity and absolute humidity
Yes. And the temperature.
and temperature.
Yeah.
Yes.
Okay. Then we learned the formulas for the heat map. I mean, we created the heat map also. Just run this program. You'll be able to see the heat map. Okay. So this is showing you the negative values, the most negative and the most positive values. And according to it, the color combination of these.
Yes, okay.
According to the scale, it is moving from dark purple to peach color. Okay. Darkest is having the most negative value.
Yes, like
Okay.
these.
Yeah. Now just scroll down. Okay. So see, we had, I mean, two formulas, two functions we had defined, error underscore product and square underscore errors. Okay.
Okay.
This also you might be remembering we had done in the last session. Panda series we had created for data, I mean, for target and feature variables as your temperature and your RH, relative humidity, on the X and the Y axis. Okay, and then we calculated the slope and the intercept. So
Yes.
this was then we had to find the equation for the best line. Just scroll down. Okay, so this was the equation, relative humidity y is equal to mx. According to that equation, relative humidity is equal to this much, right?
Yes.
And
Okay.
this was called as the regression line. Okay, we had plotted the regression line in the scatter plot between your relative humidity and temperature as on the x and the y axis. Okay,
Okay.
just run this program as well. So this was the regression line, right?
Yes.
Now can you just tell me what is the use of this regression line and why we are doing this analysis?
In a data set, the regression line is like a representation of the data because we can see here the data is all over the place. And this regression line is kind of showing the average of where the data is going.
Yes, exactly. So into any data frame we can analyze this thing, right?
Yes.
Okay, now just scroll down. Very nice. So, and then after this best fit line, and after calculating your two terms, which was the intercept and the slope, right? We had seen these ready functions. See, we had defined those are the user defined function, right? Now from sklearn module, we had seen the ready-made functions of these two terms, intercept and slope, using the linear regression. right?
Yes.
Okay, so this was the functions we are ready-made using it, and we just printed the mean squared error, mean absolute error, and the R2 score values. You can just scroll down and check the previous code. That's all we had learned in the last session. Yeah, just run this. If you have any doubts in this, you can just ask me. Otherwise, we'll move forward. Yeah, this
And
is
this,
clear. Yeah.
these are all just using the formulas. Uh,
Using the sklearn module, we had used the module called linear regression and the functions of the linear regression, right?
yes, we did. We made that last time. I
Yeah,
remember.
yeah. Now just scroll down. Now just come down to the activity and the most important things. Highly accurate regression model. We had seen that R2 score, the R square value, this should be close to 1, right? And the MSE, the errors, the erroratical terms, MSE, RMSE, and MAE, these values should be close to 0. This is the ideal one which we learned, right? So, for checking whether our analysis model is an ideal one or not, we'll be doing the residual error analysis today. Okay, and if it is ideal, the R square value will be close to 1. MSE, RMSE, and MAE, these three values will be close to 0. That's what we have to check, right? Okay.
Okay.
So just come down to the activity 1. Yes, residual error analysis. Okay. So y is equal to b naught plus b1x plus e. Now this is your, see, we have the x as the independent variable here. Okay. Capital Y, this is showing the response to the independent variable. This is the predicted value of the dependent variable, right? And your B naught, this is the intercept by the best fit line, okay? And B1, that is your slope of the best fit line, okay? These two, B naught and B1, they are called the regression coefficients. We learned about coefficient also last time, okay?
Yes.
Yeah. And
Yes.
this small e is denoting your error, the random error. Okay, fine. So we have to create a histogram for the errors obtained in the predicted values for the train set, right? So do you have any guesses how will we create a histogram? We had
Uh,
learned the function. Can you tell me the function for creating the histogram?
it was his.
Yes, very nice. Good. You remember? We had learned a lot back. Okay, great. So let's start it. Just take a variable errors underscore train. We'll calculate the predicted value for the error value first. So errors underscore train is equal to, we had taken the variable as y is equal to y underscore train underscore reshaped minus y underscore train underscore predicted PRED I have taken. Yeah, okay. Now take a plot figure. So PLT dot figure fig size is equal to 12, 4, DPI is equal to 96. Then call the function, yeah, correct. Then call the function hist, PLT dot hist for histogram, for creating a histogram. First parameter is your predicted value of y, so that is errors underscore train, comma, bins is equal to Sturgis, and edge color is equal to, you can take it as magenta M, small m. Okay. Then you can give the title as plt.title histogram for errors in the prediction on train set. Histogram for errors in the train set. We are taking the train data set, right?
Okay.
Then we'll create the AXV line. So plt.axv line in the bracket x is equal to errors underscore train dot mean. Comma label is equal to mean of errors. I mean, you can print the message mean of errors is equal to errors underscore train dot mean. You can print up to 3 decimal places, so dot 3. Excuse me. And you can give the color of AXV line as red, comma color is equal to red. You do not do it up to 3. Yes, correct, that is correct. Dot 3f. R will also work. In this generally PLT, we just give the first letter of the color. Okay.
Okay.
So this AXV line is completed. Then you can give the X label, plt.x label, train set errors. Also plt.legend and plt.show.
Would train set be 1 or 2 words?
What?
Would train set be 1 or 2 words?
Here in the AXV line or what?
And just like the labels and everything?
Yes, it's okay. We are taking on the x-axis as the train set errors only.
Okay.
Okay, just run this program. Okay, what is the error? Hist is showing the error. Bends is equal to Sturges. So that Sturges will come in the quotation marks.
Okay. Okay, it's working now.
Good, yeah, it has come. So you have the histogram for errors in the train data set. Okay, the edge colors, as you can see, it is given magenta, and it is showing the maximum error on that AXV line. Okay, it is approximately 1000.
Okay. What the 3F be with?
Which are you asking?
The mean, it's
Yeah,
supposed to be like
that is
decimal.
not working. It should be up to 3 decimal places only. So we'll check with the format. You have written x is equal to errors underscore train dot mean, right? And show me the code once again. Okay, label is equal to f mean of errors is equal to errors underscore. Just, yeah, now it's coming. See. Okay, and mean of errors is coming as 0.
Okay.
Which is the ideal case.
Yes, okay.
Okay. See, this is a normal distribution curve. This curve, which is, I mean, if you join the top lines of these histogram, you'll find that this is a normal distribution curve. And if the mean of the errors between the actual and the predicted value is not equal to 0, then you need to rebuild the linear regression model again. Okay, with a different, we have taken relative humidity and your temperature as the target and the feature variables, right? So if you're not getting the mean of errors as 0, then you need to change the target and the feature variables again. Okay, this indicates that your target and the feature variables are independent. We're getting a smooth normal distribution curve for this. Okay, understood
Okay.
this very well?
Yes.
Okay, now the normal distribution curve formula, rho x, this is read as rho, okay, is equal to 1 upon sigma, that was your coefficient, right? Square root of 2 pi and e to the power of minus and this term. This we had learned in one session. Do you remember this formula, probability density function?
It was from a long time ago.
Yes, it was long time ago, but we had learned this formula. So we'll be creating a normal distribution curve for the errors obtained in the predicted values for the train set. Okay.
Okay.
So for this, what we'll be doing is we'll be defining a function. So just define a function called prob underscore density underscore func. In the bracket, you can pass on the series. In the bracket, as an input, we'll pass the series, which we're taking the panda series. Okay, correct. Now inside the function, just take a constant variable. We'll define a variable called const, C-O-N-S-T, capital. And this constant will be the power of your E. Okay. Now the power of E in the formula is what? 1 upon 2 sigma square x minus mu square. Okay. So this sigma is your standard deviation, right? Standard deviation can be calculated using the function. What is the function for calculating the standard deviation?
Standard deviation.
It is STD. Okay.
Yeah.
So CONST, you can make it as complete capital because we'll be using it as a macro. Yes. That is equal to 1 upon the formula we are applying, right? 1 upon, in the bracket, series dot standard deviation is STD. So series dot STD, yeah, come out of the bracket and come out of this function and multiply it by, yes. Then you have the numpy array. So np dot sqrt, and we are taking this 1 upon sigma square root of 2 pi, the first term. Okay, we have divided the formulas into two parts. So just check the first part of the formula. It is what? 1 upon, this is called as sigma.
1 upon sigma times the square root of 2 pi.
Yes. So square root of what we have to do? Square root of 2 pi. So SQRT in the bracket we'll pass on 2 times NP dot pi. It won't be 1 upon. Yeah, 2 times NP dot pi. Okay. So this we have constant is equal to 1 upon series dot std multiplied by np dot sqrt, np times 2 times np dot pi, right? So this is the first term. Pi is not a function. We had seen that in the numpy arrays, pi is your keyword. Okay. Just check all the brackets.
Yes, we'll do that.
How many brackets will be coming in the end? Yes, correct. Okay, yes, good. So this was the constant we had defined. Now we'll be defining the power of E. Power of E is your 1 upon 2 sigma square x minus mu square. right? So just take another variable, power of E is equal to, yes, now just define this. In the bracket, series minus series dot mean to the power of series minus series dot mean, you can take in the bracket. Series minus series dot mean to the power of 2 upon, again the bracket, yes, inside the bracket 2 times series dot var. You remember this panda series function which returns the variance of the series, right? So 2 times series dot var, correct. Okay, now just press enter. So we have defined these two. Now you just need to define the exponent and multiply these two terms. So just write down new array is equal to constant into, yeah, new array is equal to constant multiplied by np.exp, that is the e, np.exp to the power of, so in the bracket power of e, in the bracket power of e, automatically it will go. This is the exponent we had defined. Now just return the new array.
Okay.
See, now we have defined this function. This won't give the output. We have to plot the normal distribution for errors in the prediction of the trained set, right? So quickly define a figure outside the function. plt.figure for x size is equal to 12,4, dpi is equal to 96. In this only, you have to define the normal distribution curve.
Okay.
plt.scatter. We are calling the scatter function for the normal distribution curve. So plt.scatter in the bracket errors underscore train, and you have to call the function which you defined, comma. For the y-axis, we'll be calling the function prob underscore density underscore func, and in the bracket, we'll pass the series as errors underscore train. Okay, then just quickly define the title as normal distribution for errors in the prediction of the train set. Your speed is excellent. Okay, then plt.axv line, you can just copy paste the same thing from above, the axv line. X is equal to errors underscore train dot mean, label as that. Color you can change to red.
Okay.
You can take the X label legend and show all the things.
Oh. Okay, then okay.
Because for the same histogram, we are creating the normal distribution curve.
Okay.
Okay, now just try running this, because we have called this function which we had defined as probability underscore density underscore function. Now just check. The mean of errors are 0, right? And the normal distribution for errors in their prediction in the train set. We are having this as the curve. Okay, which is almost the maximum values. Just see. In the normal distribution curve for errors, just see. Maximum values are lying between your 0 and 0.5. okay, and the best fit line, the AXV line, that is your at 0. That means the mean of your errors is 0, which is the ideal one. Okay.
Okay.
So this is the normal distribution curve. We also have the same normal distribution curve in the skippy.stats library, which is norm.pdf. Okay, so we'll be calling that function. So just copy paste the same lines, plt.figure, fig size. And instead of calling the function which we have defined from line number 7, yes, plt.figure.
Oh,
Yeah, just scroll down. Now we'll be calling the readymade function. So you have to insert the library first. So from skippy.stats import norm. First of all, just import the library of the norm from skippy.stats. It is SCI, forgot this module, SCIPY. The norm is the module which we have to import. Okay. Now in the scatter function, that fixed size is okay. In the scatter function, what we have done, we have called the probability density function. Instead of that, plt.scatter, errors underscore train, comma, we'll call the function norm.pdf. Now norm.pdf is taking your two inputs. So in the brackets, write down errors underscore train and errors underscore train dot mean. And the standard deviation, the three parameters it is taking. Errors train, errors dot mean, and errors underscore train dot std, the standard deviation, comma. Yeah, then everything is okay. You can change the title also, or it's okay. We are just doing the same thing using the non-df. So you can just run this and check. So this is the normal distribution curve with the 0 as the best fit line, right? And the mean of errors as 0. Okay, so this is the thing which we are using from the Skippy library, and that was the thing we had defined the function. Okay, now just scroll down. So we got a basic idea of this thing, how to create the normal distribution curves. Okay, now we'll repeat the same thing. Just check once your, just a minute, just give me a moment. I'll just check with your code of, I think you've made a mistake in the formula writing. Just wait. Let's reload your file once again first. The normal distribution which was coming previously, just check that once again. I've corrected the formula. Yeah, just run it. Now it's coming okay. The same formula we had used. Okay. in the probability density function. Now the one thing which we did using the train set, you have to repeat the same thing for the test set. Okay.
Okay.
Yeah. So you can take the error, first of all, just create the histogram for the errors obtained in the predicted values for the test set. So you can quickly copy paste the above thing and change it for the test. The histogram, take the histogram part.
Instagram is
Yes. Yeah. We have to just check whether this prediction model, the test one, which we had taken, this is also accurate or not. Okay. So that we can check using histogram only. And you have to change the errors underscore train also. It will be errors underscore test. We are taking for the test data set. Yeah, and we had taken the variable as y underscore train underscore test. Y underscore test and y underscore test.
okay.
Okay. Okay. So just check the mean of the errors. How much is it coming?
Negative 0.467.
0.467. So what does this indicates? That is it a 100% accurate prediction model?
No.
No, because the mean of errors is not zero. And as we can see, that the AXV line is also not in the exact center. Okay,
Okay.
fine. Now let's learn the two terms which are very important terms, homoscedasticity and heteroscedasticity. It's big terms. Come down to the activity 2, yes. Do you know the terms homo and hetero? You might have learned it to science.
Yes, like same and different.
Yeah. So if I talk about the same things, then it is
Homo.
homoscedasticity and heteroscedasticity. So here we'll be, I mean, see, we have checked the mean of the errors. Okay. Now you also need to check the trend of the scatter plot, where it is, I mean, the most scatter points are where and the least scatter points are where. So we'll be plotting the scatter plot between your errors and your feature and the target variables. Okay. And there should not be any trend for the same. I mean, if it is a scatter plot, then it should have a line at zero. The mean of errors should be zero. So the best fit line will, the AXH line or AXV line, that will be also at zero level. Okay. So
Okay.
we'll be creating a scatter plot between the errors and the independent variable for the train set to see whether there is a kind of relationship between these two or not. Okay. So you have to create the scatter plot and we'll be using the scatter function, right? So just write down plt.figure, fixed size is equal to 12, 4, dpi is equal to 96, and then call the scatter function for x train and errors underscore train as your x and y axis. Remember you had done this mistake. This x will be capital. Last time also we had done it. Okay.
Yeah.
So yeah, then just create a horizontal line, AXH line. Yeah, y is equal to, here we are taking the y-axis, so y is equal to errors underscore train dot mean, color is equal to r, and label is equal to f mean of errors is equal to errors underscore train dot mean dot 3f. Yes, so that's correct. That we've created a horizontal AXV line, and then the legend and showing the legend and showing the plot.
Um,
It is not showing the AXV line. Okay, just wait a moment. Y is equal to errors underscore train dot mean. Can you tell me the error which you've created?
it says unsupported format string.
Yes. So that is your error in the AXH line only. Y is equal to error underscore train dot mean. Just check the brackets and everything. F mean of errors. Your mean is a function. So errors underscore train dot mean. Yeah.
Okay.
Okay. So here we have the AXH line as the horizontal line on 0. What does that mean? Can you tell me?
That means the average or the mean of the y values here would be 0.
Yes. So that is that is the thing, that it is not changing, right? From the leftmost point to the rightmost point in the scatter plot, it is almost 0. So is it a homo or a hetero?
A homo.
Homoscedasticity, correct. So homoscedasticity, homo is same. It is not changing. That is why we have called it as homo. And your term cedasticity, that is your variance. Okay.
Okay.
So here we are having a constant variance. That is why it is homoscedasticity. Okay. And homoscedasticity is always good for us. If I talk about the normal distribution curve or this thing, the mean of errors, it is 0. And that is why it is a homoscedasticity scatter plot, right? Now we'll be creating this same thing, the scatter plot between the errors and the dependent variable for the train set. Okay. Just check whether they are your homoscedasticity or not. Okay. So just copy paste this thing quickly. Plt.figure and the scatter plot. Yes, completely. And instead of x train and errors underscore train, we'll be calculating it for y underscore train. So in the scatter, plt.scatter, y underscore train, and that's it. And also in the AXH line, you can just call it as train. That's correct. Okay. Now just run this. So can you tell me what is this showing? This is again showing the mean of errors as 0, right?
Yes.
Yeah. Now there's a clear trend between the errors and the target variables for the train set. Okay.
Yeah. Okay.
But here, just see the variance in the errors, that is varying from left to right, as you can see in the scatter plot. There are points which are below your 0 and above your 0 in the scatter plot, right? If I
Yeah.
talk about with respect to your predicted values. So this will be not good for us. And there are changing things between your AXH line. So that is your heteroscedasticity, not the same variance, right? So this is not
Okay.
good for us. Okay, Sonali, are you getting my point?
Yes. So here it was
On the,
scattered all
yes,
around.
yeah,
So it was the same here, but here this one is down there and this one is up there, so it's not
yes,
the same type.
yes, the
Okay.
variance is not same, and that is why it is heteroscedasticity. Okay, so I hope you're
Okay.
clear with these two terms.
Yes.
Okay. Now come down to the activity 3. the multiple linear regression. See, we saw the coefficient terms for the, we saw the regression coefficients for the two independent variables, that is your b naught and b1, right? Now we can have it as a series, b naught plus b1x1 plus b2x2 and so on, right? So these, we saw it for one independent variable, that is x. Now we can have multiple independent variables, x1, x2, x3 and so on. We can check it for the complete series also. Okay, so in order to predict the relative humidity, which is the target variable we took, and we'll be considering the date time object now. Okay, the date time column. So we
Okay.
have the formula for RH. RH is equal to B naught plus B1 CO plus B2 C2 H6. These are the column names we had seen in the data set, right? So your x1, x2, x3, we are taking the independent variables as your name of the columns.
Okay.
Okay, you can just scroll up quickly and see the name of the columns. They are your CO, C2, H6. On the top, it was there.
Uh,
We had using the describe and the info function. Yes, here, yeah, here. These are the name of the columns,
okay.
right? So same thing, CO as the first one, C6H6 or C2H2. So that way we are taking the temperature, relative humidity, and absolute humidity. Those column names we are taking as your independent variables. Okay.
Okay.
So as we have done for the two, we had done for temperature and relative humidity, right? Now we can take the independent variables as all your columns. Getting my point? And
Yes.
why we are doing it? Because see, we want to check the error analysis for each of the independent variables.
Okay.
And if it comes, see, we can consider right now we consider the two feature variables, the temperature and the relative humidity. If we consider three feature variables, suppose your COT and AH, and the coefficients are 14, 2 and minus 3 and 5. So what will be the equation? Just it is given, see, y is equal to, just replace the coefficients with your x values, right? So 14 is the constant, right? Plus temperature, we are taking the second one. So 2x1, right? Then minus 3 we are taking as AH. So minus 3x2 and 5x3. So that way we can replace the coefficients with your column names and the independent variables as x1, x2. So, this RH will have all the columns also, and we can take two or three or four independent variables also. Getting my
Okay.
point, right? So,
Yes.
see, we'll be doing in the next class what? Estimating the values of these coefficients.
Okay.
Okay. So, can you quickly tell me what all did we learn today?
Yes. Okay.
Yeah.
So we started with this. We started with the scatter plots. Oh, first we went over everything we did in the previous classes, and
Yes.
then we learned about the regression line and this. We did the scatter plot here,
Yes.
and then we went over some more like these are mainly the formulas uh, that we imported from sklearn metrics, and
So,
then
what was the function which we learned from Skippy library?
uh, one of them was coefficient and one of them was intercept
Yes.
for the slope and intercept.
Very good. Just come to the class once. Okay, remember each and everything for your focus. I reward you 10 on 10.
Thank you.
Okay, now you can just come back to that session.
Okay. And then we And then we did some histograms and scatter plots. We learned about the mean, how zero is good, and and then we went on to learn about homoscedasticity and heteroscedasticity.
Yes. So what are these two terms, homo and hetero?
Uh, Showing about the variance, whether it's same or
Yes.
different.
Showing about the variance. Good. If it is same homo, then and if it is different than hetero.
And
Yeah. And what does the term pseudasticity mean?
variance.
Yes. So we are just checking the variance of the two.
Okay.
Sonali, any doubts if you have in this, then you can just ask me. Otherwise, we'll have a quick recap of the next project because all your projects are completed till now. 60 projects you've submitted. That's wonderful. I mean, you've submitted all your projects on time and your project submission report is 100%. So keep up the same pace and do complete your projects on time as you're completing. I'll just give you a brief overview of the project, which I'll be giving you in the next one. So we have a total of 5 activities. First of all, we have to analyze the data set. Then we have the train and test splitting of the data sets, right? Then the model training, which we had learned in the next last session. Then from here it goes to the activity 4, which is your model prediction, and the last one will be your residual analysis. Okay. So analyzing the data set is your, we are importing all the modules, loading the data set that you remember, and printing the first 5 using the head function, and then checking if there are any null values in any of the columns, right? Then treating them. So this we had been doing since last 10 classes, right?
Yeah.
And then what you have to do, you have to create a regression plot between your
Okay.
years experience and salary. I'll be giving you the new set, that is your number of years of experience and the salary. So these, using these two columns, you have to create the regression plot. Okay. Then in the
Okay.
activity 2, you have to create the train test split, which you've been already doing. Then the model training has to be done. Okay. Printing the shape, the dimensions of the reshaped ones, like we had done for the train set. What we had done, we had reshaped the values into x and y axis. So the same thing you had to do. Okay.
Okay.
Then calling the fit function. After that, for the model prediction, you have to predict the target variables values for the test set and print them, and predict the salary of a person having 15 years of experience. So that is the parameter which I have given. You have to predict the salary of a person having 15 years of experience, and according to the histogram which you'll be creating, you have to find out the best salary you can offer to the candidate, right?
Okay. So that will also be a histogram.
Yes, you have to create the histogram for the errors, and what is the mean of the errors you have to calculate according to the histogram what is given, and you have to write in the answer.
Okay.
Okay. So just try it out. This is a very simple project related to the thing which we learned today only. So try completing it today or tomorrow so that we'll go with the next session then.
Okay.
Anything else, Sonali, if you want to ask?
No, I don't.
Nothing? No doubts? Okay.
Yeah.
For your passion and for your creativity also, I award you 10 on 10. You're doing excellent in all your sessions. So wonderfully well. And have you applied for some online certifications for your Python? You asked
Uh,
me.
I have not yet, but I will do that soon.
Okay, just find out, and in case you find, in case you're not unable, you're unable to find out some of the links for the online certification programs, you can just text me up or mail me up. I'll just send you the few links for the online certifications. That's excellent. I mean, if you're fighting some other exams also.
Okay.
And in your school also, do you have the coding contest kind of things?
Uh, we should. They're mainly for people who are taking the coding classes,
Yeah,
so I'll have to check with that.
yeah. I mean, if you
Yeah.
have, you can apply for that also, because now you have almost completed, we are almost completed with the basic Python, the data analysis part. Now from these sessions, we are moving towards your artificial intelligence and the machine learning, which is,
Okay.
something difficult, but I hope you will be able to do it. You're excellent in everything.
Thank you.
Okay. Okay then. See you in the next session.
Okay.
Bye. Take care. Bye bye.
Bye. Thank
Yeah.
you.